Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 with the course code ICT501. The group is DCS2403A. For this semester, our project is RedBus e-ticket database management system, and this present to Madam Marhainis binti Jamaluddin.
Now we move to the table of content. First is group members, second is project description, third is objective, number 4 is the ERD, that is entity relationship diagram, and lastly is the project demonstration.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fidinya dan Abdul Wali. The matrix number is 2024776123.
My name is Muhammad Fazil Nabi Muhammad Sabri with the door matrix 2024905599.
My name is Muhammad Alifdini bin Ibrahim. My matrix number is 2025301993.
Assalamualaikum, my name is Adam bin Arush. My matrix number is 2024568687.
We'll proceed to the project description. So I'd like to present for our project that is focused on the developing a database system for managing electronic ticket like e-ticket data in the bus transportation sector. The system is specifically designed to support transport operators by providing key features such as: first, tracking passenger by destination, so operators know where passengers are getting on and off. Second, monitoring the number of the buses per trip. It helps with efficient fleet management. Third is generating monthly passenger statistics, so it gives insight into ridership pattern and trends. Our goal is to improve how RedBus manage, store and process important transportation data. By doing this, the system ensures that data is not only secure but easy to access and analyze. It also supports RedBus existing services such as real-time seat selection, mobile app integration, and automatic booking management. Ultimately, this project aligns with the RedBus mission to enhance the customer experience and boost operational efficiency by fully digitizing and streamlining bus ticketing and transport data.
Okay, so I'm going to present about the objective. So our project aims to provide local operators with a powerful backend system that offers real-time data access and ensures operational transparency. For the first objective is to calculate the number of passengers who buy a ticket by destination, allowing operator to track demand for each route more accurately. The second objective is to display the number of tickets sold for each month in 2025, which helps in identifying monthly trends and peak travel periods. And next is to calculate the total numbers of tickets sold in January, giving a focused view of the year's starting performance. Next is to calculate the average number of bookings per month, which provides a baseline to measure performance against. For the last objective is to identify the destination with the highest number of bookings, enabling better resource planning and marketing strategies. That's all from me.
I will be presenting the entity relationship diagram for this database management system. We begin with the customer entity. Each customer has a unique customer ID, which is the primary key, along with their name, email, and phone number. Customers are the users of the system who make bookings. Next, we have the booking entity. The book ID is the primary key. Other attributes include book description, total amount, and book date. There's the foreign key, customer ID, linking the booking to the customer who made it. A single customer can make many bookings, establishing a one-to-many relationships from customer to booking. The ticket entity holds information about each bus seat that has been booked. Ticket ID is the primary key. It includes seat number and passenger number, which can be different from the customer who booked. It has two different foreign keys, trip ID and book ID, linking it to the trip and the booking entities respectively. Each booking can have many tickets, and each trip can also have many tickets, making this a many-to-one relationship in both directions. The trip entity represents a specific scheduled journey. The trip ID is the primary key. It includes details like trip origin, trip date, and trip time. Foreign keys include bus code, which links to the bus entity, and desk code links to the destination entity. Each trip is operated by a single bus and goes to a specific destination. The bus entity stores data about each vehicle used for trips. Bus code is the primary key. Other fields include bus description, driver ID, driver name, capacity, and register number. Each bus can be assigned to multiple trips, making this a one-to-many relationship from bus to trip. And lastly, we have the destination entity. Desk code is the primary key. It also includes the destination name. Each destination can be associated with many trips, creating another one-to-many relationship from destination to trip. This ERD captures all the core components of a bus ticket booking system.
I'm going to present the project demonstration for RedBus e-ticket database management system. So we have created about 6 tables overall for this project. We go to the first table, which is the bus table. This table is related to destination, which a bus may have many destinations and a destination may have many buses. So the bus table have 6 columns right here. The bus code is the primary key, followed by the bus description, driver ID, driver name, capacity, and we have the registration number for the bus. Next table is the destination table. There are only 2 columns for this table. So the destination code is the primary key, followed by destination name. Since these 2 tables is related, so there are a bridge between these 2 tables, which is the trip. So we have created a primary key for this table, which is trip ID, followed by the 2 foreign key, the bus code and destination code. And we have 3 columns for the trip table, which is the trip origin, trip time, and trip date. The next table is table ticket. So this table is related between 2 tables, which is the trip and the booking. So the ticket ID is the primary key for this table, followed by seat number and the passenger number. The 2 foreign keys for this table is trip ID and book ID. A customer can make many bookings. So these 2 tables is related each other, and the primary key for the customer table is customer ID, followed by customer name, customer email, and their phones. The next table is table booking. So the primary key for this table is book ID, followed by book description, which is the destination the customer booked for, and followed by total amount, the total ticket price booked by the customer, and we have book date, also the customer ID, which is related to the table customer. SQL queries. There are 5 objectives for the whole project. So we have 5 SQL queries to support each objective. The first objective is to display number of trip origins and the bus route for the trip. So we select the column trip origin and the bus description from the table trip and bus. Since we select from the 2 tables, we have to create the relationship. So the bus code from the table bus is the primary key equals the bus code from the table trip is the foreign key. We have to group by since there is an aggregate function. So the bus description is the single column. We have to group by the single column. The second objective is to display the destination booked by the customer and the number of tickets sold for each month. So we have selected the book description, book date, and ticket ID. Those columns are from table book and ticket. Since we use the 2 char statement, this statement is to convert the book date into the month format, and the count function is used to count the number of tickets. And then, since we selected from 2 tables, we have to create the relationship between those tables. We use the book ID from the table book as the primary key equals the book ID from the table ticket as the foreign key. Since this is an aggregate function, so we have to group by book date, since book date is a single column. And we want to sort from January until December, we have to convert first the book date into format, and then we use the order by statement to sort from the month of January until December. Objective number 3, to calculate the total ticket amount sold for the month of the year 2025. We have selected the book date and the total amount from table book. So we convert first the book date into the month format, and we use the sum function to sum up all the total ticket amounts followed by months. So we use the concat statement to combine the RM and the numbers. So all the columns are from table book, and the condition must be from the year 2025. So we use the where statement to and then we convert the book date into the years YYYY, set the condition from 2025. And then, since this is an aggregate function, we have to use group by, and then we want to sort from January until December, and we use the order by statement. Objective number 4 is to calculate the percentage of customers who book the ticket per month. We have select the book date column, followed by customer ID. So since we want to calculate the percentage, we have to create a formula for the select statement, and we use the count function to count the customer ID, and we divide it by the subqueries. We select the count customer ID from the table book, and we multiply it 100, and then the answer will generate the percentage of number of customer. So this columns is selected from the table book, and since there is a group function, we have to group by the book date, and we convert it into the format because we want to sort from January until December. The last objective is to find the highest booking destination. So we select the book description and book ID from the table book. So the group by statement is used since this is an aggregate function. So there is a condition for the group function count, and then from the condition there are two subqueries right here. The first subquery is to count the book ID, the number of book ID, and the second subquery is to find the highest we have counted before. So those columns are from the table book. That's all. Thank you.